Hello. In earlier lecture, we have seen what are the different data objects in VHDL. Now we will see what are the different data types in VHDL. Actually, what the data type is, whatever the data objects are over there in VHDL, it holds a value which belongs to a specific type. Means, in earlier example where we have seen X as a bit, the bit is a data type and X is a data object of the type data object of signal. That's why whenever we are declaring any signal, we have to say two things, that is what is its name and what is its type. Here we can see that there are different data types which are being supported by the VHDL. These types are scalar type, composite type, access type and file type. The scalar type is what? The value belonging to this type appears in a sequential order, whereas composite type has two things. One is of array type and one is of record type. Array is a element of single type and record is a different record of different types. Access, it is a provide access to the objects via pointers, and file, this provide access to the object that contain a sequence of values of a given type. Here, whatever the scalar types are over there, these scalar types are further subdivided into four different types: enumeration, integer, physical and floating point. Whatever the detailed example of this enumeration, integer, physical, floating, as well as array type, then record type, all these examples are detail given in the notes. I will provide you the notes, and the notes contain with these examples. Here I have shown you some examples of this data types. Here you can see an example which is given as a predefined data type bit and bit vector. This bit is a two-level logic only, which contain only the two values, that is 0 and 1. Actually, bit and bit vector is a predefined enumerated type of the VHDL. Here there is an example given, that is a signal Y is of the type bit and its initial value is 1. Actually, bit and bit vector has a little difference, that is a bit contained only a single element, whereas bit vector contained a bus. The second example shows that signal X is of the type bit vector and it has a 3 down to 0, means quite obvious this X signal will be having the 4 independent signal inside it, whereas we can declare it as X in bracket 0, X in bracket 1, X in bracket 2 and X in bracket 3. Like that you can access an individual part of that signal X or combinedly as a bus 3 down to 0. Here X is assigned a value that you can see it is a less than equal to. Never read it as less than equal to, it is read it as assigned to. Whenever you see such a symbol that is less than or equal to, but while reading you should take care that you read it as assigned to. Here X is assigned in double inverted comma 1101. Again, one care while writing the values in case of bit and bit vector, you must take care that whenever you are writing a value for a bit, the value must be inside a single inverted comma, and whenever you are writing a value for bus, that is more than 1, either 2, 3, 4 or any value, that must be the value must be given in the double inverted comma. Below here the two things are being shown. These are the operators in VHDL, that is a less than equal to used for signal assignment and colon equal to used for variable assignment. There is another example. It is also a predefined enumerated type of language, that is a std logic and std logic vector. Earlier whatever example we have seen which is of bit, which has only 2 values, whereas std logic has 8 values. you can see all these 8 values, that is X, capital X, that is a forcing unknown, 0 forcing low, 1 forcing high, Z high impedance, W weak unknown, L weak low, H weak high, and hyphen, that is a don't care. These are the different values which are being associated with the type STD logic. Similarly, here is another example. Here you can say that what the simulator will do, because when you go for a STD logic vector defined type, then quite obvious you must check that does it is a synthesizable, means does your synthesizing procedure is able to generate a hardware for that or not. So this thing is, out of this all these values 0, 1 and Z, these are only synthesizable, rest all the values are not synthesizable. The example are also given over here, that is the signal X is STD logic and variable Y which is a STD logic vector 0 to 3, instead of 3 down to 0, now it is 0 to 3. And assignment operator also, you can see that when the value is assigned to the operator X, because X is a variable, the assignment operator is less than or equal to, and when it is assigned a value to Y, you can see the assignment operator as a colon equal to, and the value is written inside double inverted comma. This you must take care. There is another predefined type, that is the STDU logic. It has only one extra value added other than STD logic, that is uninitialized. Okay, that's why you can say that STD logic is a subtype of STDU logic. There are also other types of are also over there. You can see Boolean. This is it has having two values, true and false. If you define any type as an integer, then it is a 32-bit number ranging from the range being given over here. And natural, if you define anything as of natural type, these are the non-negative numbers and range is also given. Similarly, if you define any real type, then the values will be given from -1 10 raised to 38 to +1 10 raised to 38, which are non-synthesizable. There are some more examples are over there. You can see that if ready, then actually it is a statement showing inside a VHDL code. If statement is it is showing an example of if statement, and ready is a Boolean. Ready is a Boolean. If it ready is a signal you might have used somewhere, and if its value is 1, then it will return true and the condition will get satisfied. Like that it will be, means ready, if you define ready as of the type Boolean, then quite obvious it will ready can hold only two values, either true or false. These two values will be held by ready. The other examples are also shown over here. Whatever the things, whatever the type we have earlier seen, these are the predefined type of languages. Similarly, you can have a user defined type also. User defined type means what? Actually, you can see here is one declaration. You can see that here the declaration of my integer type. This is the type declaration of my integer, and its range is 0 to 100. Its range is 0 to 100, means now the type my integer cannot take the value beyond 100. And you can see the example. The example is again same. The name of the means actually it is following the syntax of a signal, then keyword signal, then X is a name of that signal, and its type is my integer. And when you use the same thing, you can assign a value to it as 23. Assignment operator also you check, it is a signal assignment operator. As you can see, this is a user defined type in integer. Integer, don't forget that integer is a predefined type of VHDL. Similarly, you can have a user defined enumerated type also. I have told you that earlier, whatever the thing we have seen, that bit, boolean and std logic, these are all predefined enumerated type of VHDL. You can have a user defined enumerated type also. Here the example of the user defined enumerated type is state. This is a type declaration. That's why you can see the statement type state is st0, st1, st2, st3, st4 colon. I will tell you first which are the keywords over here. The keyword is type and keyword is. State as well as st0, st1, st2, st3, st4, these are the names given. In VHDL I will call it as an identifiers. Okay, means here the state is being declared as a type and it can hold the values from st0 to st4. And now you can see the declaration of this. The declaration is done for next state. Here next state is again the name to which I will call as an identifier. For example, for this particular thing I can say that next state is a signal object of the type state. This you can clearly say that like this. Next state is a signal object of the type state, where state is a user defined enumerated type which can take the values from st0 to st4. This particular thing will be essential when we will go for the examples of FSM. Here you can see arrays. I told you that the composite type, the array and record. Arrays may be a one-dimensional like std logic vector or bit vector. These are the one-dimensional arrays, whereas you can have two-dimensional arrays also. The two-dimensional arrays are means you can see from example it will get clear. Matrix is an identifier, that is the name given to the type, and this matrix is an array, and it is an array of 0 to 3. It is contained of 4 elements, and each element is a std logic vector 7 down to 0. Means each element has 8 locations. You may say you can say that instead of matrix, if I use a word memory, that will be a better word, because when we want to declare a memory, suppose if I want to say that 8 bit or 8 byte of memory, then I will say 8 byte of memory. Then I will same thing I can declare as type memory is array 0 to 7 of std logic vector 7 down to 0. This will be the declaration for memory of 8 bytes. In next lecture we will see the operators in VHDL.